Now we're going to talk about covalent bonds, which are completely different than ionic bonds. Ionic bonds, as you remember, are two ions that one has a negative charge and one has a positive charge, and those negative and positive charges come together and they transfer their charges to each other, and that makes them stick together with a total charge of 0. But covalent bonds, the ionic bonds will happen between somebody in one of the elements in the cations and one element from the anions, because one has to be positive and the other one has to be negative, right? Well, covalent bonds only happen in the nonmetals group. Remember the staircase that separates the metals from the nonmetals? So the covalent bonds only happen with these elements. When these elements are put together, because these elements will all have a positive charge if they're ions, so that's not going to work. So this is not going to be ionic bonding. This is going to be something else, a totally different way of bonding. So when you have covalent bonds, what you want to do is you want to write out the Lewis dot structures. Let's take let's take N for instance. Or no, actually, let's take sulfur for instance. Sulfur is right here, and sulfur is in this row, and this row is 6A. So sulfur is going to have 6 electrons surrounding it in its outer shell. So what you do is you write down the element, and then you're going to put 6 dots that represent the valence electrons around it. But you don't just go 1, 2, 3, 4, 5, 6. That's not how you do it. You have to go 1 dot in each of the 4 spaces first. You have to go all the way around, and then you double up with any leftover electrons. So sulfur has 6, so you go 1 dot, 2 dots, 3 dots, 4 dots, and now you have 2 left over. So you double up here, 5 dots, and you double up there, 6 dots. So this would be the Lewis dot structure of sulfur. So let's do another one. Let's do nitrogen. Nitrogen is in the group 5A, so nitrogen is going to have 5 dots around it. So we go 1, 2, 3, 4, and it needs 1 more, so we're going to double up, 5. So that would be the Lewis dot structure for nitrogen. Okay, now we're going to put these all together. And actually, let's do one more. Let's do oxygen. Oxygen is also in group 6A. So we're going to have oxygen, 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots. That's going to be the Lewis dot structure for oxygen. Now, let's try to put these together. We had sulfur, and let's see, how many dots was that? Sulfur is in row 6A, so sulfur has 6 dots. 1, 2, 3, 4, 5, 6. And oxygen is also in group 6A. Let me make sure. Yep, see, oxygen is also in group 6A. So oxygen is going to have 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots. All right. Now I'm going to write these differently just for explanation's sake. We're going to put 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots, because you don't have to go around in a circle clockwise. It's just kind of random where you put the dots, as long as you put 1 dot on each position before you start doubling up. And here's oxygen. 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots. Okay, now if you notice in the octet rule, everything tries to get 8 valence electrons, or electrons in its outer shell. And that's all we're concerned about with is the 8 electrons in the outer shell. We're not worried about actually how many electrons these elements have. We're just worried about how many electrons are in the outer shell, or the outer energy layer. So if you look at this, there's a dot missing right here, and there's a dot missing right here, because 8 electrons would have 2 dots on all 4 sides, right? So there's a dot missing right there, there's a dot missing right there. So what these guys do is they share their dots with each other, so they can have 2 dots between the 2. See how these have 2 dots taking up the space, the space for the 2 dots on both the sulfur and the oxygen. See, they're sharing their dots, or they're sharing their electrons. But that's not all. Do you notice that there's still an empty space for a dot over here, and there's still an empty space for a dot over here? Well, so these kind of bend over, and this shares its dot in this position for oxygen, and this shares its dot in this position on sulfur. So we have sulfur and we have oxygen, but the shared electrons that they're sharing, so they can each have 8 dots in the places, are these 2 pairs. So now sulfur has 8 dots and oxygen has 8 dots around it. Now how you write that, when you share the dots, those shared dots, we designate those shared dots. See how these 2 dots are shared? One from sulfur and one from oxygen, but they share them, so they're both taking up those spots for 2 electrons. When you share 2 dots like that, you draw a little line, and the line is for 1 dot from oxygen, 1 dot from sulfur, and you draw a little line between them. Now these down here, these kind of move because of gravity. So these move into the center so they can share a lot easier. So it's a shorter It's a shorter length between the two dots. And so we go ahead and put them in between. Here's a dot from sulfur, here's a dot from oxygen, and we have two bars right here denoting that they're sharing these electrons. Because remember, covalent means cooperate. So these guys cooperate by sharing their electrons with each other. So you end up with a structure that looks like this. And see now, if you count, if you draw a circle around the sulfur, and you draw a circle around the oxygen, each of them has 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And oxygen too. Oxygen also has 3 electrons, or 8 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. So perfect. So that's how you draw this. You're going to draw this double bond, and this is called a double bond because obviously there's 2 of them. There's 2 bonds. And these are called covalent bonds because they've cooperated and they're sharing their electrons so they can each have 8. Okay, so that's a covalent bond.